invitation to give you this talk about computer simulation on fire firing facade. It's computer simulation study on building facade design and its influence on propagation. So it's not a topic focused in fire retardancy, but it is more about fire behavior, fire dynamics. But I hope you find it interesting for the fire safety point of view. So this research that I'm going to present you was developed in collaboration with the Catalan Institute of Wood and the Architectural Building Department and the Fire Laboratory of this school belonging to the Polytechnic University of Catalonia. According to different experts, fire spreading through the facade is one of the most common and dangerous spreading pathways in a building. In this area of the building, there are many factors that facilitate the dynamics of the fire, such as the unlimited amount of oxygen, the verticality of the surface, the pressure difference between inside and outside of the building, wind, humidity, etc. Therefore, the vertical spread in a facade could occur even when cladding materials are not combustible. Several cases of fire in buildings have shown the hazard of this kind of propagation. Here we can see an image of a couple of examples. One is the Windsor building in Madrid in 2005. This building burned totally and the facade was very involved in the propagation of fire. And the other one is the example that Laia showed us before. Is this residential building in 2005 in France, in Montpellier. In this event, fire spread from the first floor to the top of the building in less than 15 minutes. So if you see the video, was very fast and dangerous, the situation of fire in this case. An event of fire through a facade may originate from outside of the building due to hot coals, either by a fire near the building or a wooden area in flames. Also by an element burning in the front of the facade, that is the case of every element, like a burnish element. But the most dangerous situation, and statistically the most frequent, is originating in a compartment in the same building, and then there are the spreading outwards through the windows. So it's the most frequent. In this study, we only will focus in this last case. That is to say, from a post-flashover situation, like I mentioned before about the different stages of the fire, and one is the flashover, and once flashover occurs, then could be the situation of propagation on the facade, because the fire it propagates through the windows. As we know, fire is a complex phenomenon. The behavior can change due to different factors, such as fire load, the thermal properties of the materials, the ventilation factor that is very important, in fact, the temperature, humidity, and the geometrical factor, among others. But the focus of this research is in this last case, the geometrical factor. This is very important from the architectural point of view. I'm an architect, so that is very important for me because through the design of the facade, we can to established some passive measures of protection, the same design of the facade. The type of the facade and the design elements of the facade could have a positive or negative effect on fire spreading depending of its size and location with respect to the windows, especially. Talking about a little bit on the regulation in the Spanish context, in general, the provision of the Spanish Building Code, the CTE, on external fire spread is perceived as insufficient to address the risk associated to the fire spreading through the facade. This document, the CTE, addresses with this situation in a very general way. So this is a problem because many factors affect the fire propagation in the facade. This document don't do any reference to typologies of facades or any element that in fact they have a lot influence, a big influence in the fire behavior and the fire propagation. In general, the specifications of the regulation say that in order to prevent external fire propagation, the CTE stipulates a generic protection of not combustible material is an spandrel. This is an element named spandrel. The 1 meter minimum with a fire resistance of 60 minutes. EI, like I mentioned before, the difference between reaction and resistance. This is the resistance of the element. And this element separates the windows from one floor to the other floor. They have it's necessary that element be 1 meter minimum. And this measure also specifies that this element can be offset by a projecting element provided the sum of two elements, that is this case, sum at least 1 meter. The only document that refers to other aspects more related to the design of the facade is the Municipal Regulation of Barcelona. In particular, contains a reference to brise-soleil elements and stipulates that this must be open at least 75%. Brise-soleil element is this kind of elements, the external layer of the facade is for the solar control. And this document says that this element must be open at least 75% in the total surface permanently. So is the only specification about design of the facade or an element. So the objectives of this research are three. This study deals with the influence of the geometry of the facades on the fire dynamics, especially in relation to the mechanisms that promote the vertical fire propagation. Moreover, we analyze the level of protection provided the measures of the specifications, the CTE. In particular, we evaluate three aspects. One is influence of the geometry of the windows in both situations, the size and the shape of the windows. B, the influence of the different location of the outgoing elements relative to the windows, in interposition, and relative to the whole facade. And C, the influence of the solar control element called brise-soleil system in two scenarios, 75% open and 92% open. So, as you see in the title, we use computational fire dynamics to carry out this research. We use field models of the computational fluid dynamics to evaluate these aspects. Especially we use FDS as the software fire dynamic simulator. Is the more used software, more reputed software worldwide. I will mention only a few characteristics of the scenario. The scenario consists of a 3-story living space of 4 meters for 490 meters. It's like a cubicle of, in a laboratory, a big scale, but it's just a model. Each floor is 250 meters high and is separated by a concrete floor, so it's a material non combustible. The characterization of the furniture elements are based on some data extracted for database, so FDS. The software in version 4 have some library of materials and elements. Each cell of the control of the domain is uniform 10 by 10 by 10 centimeters. There are 2 different areas very important in this domain, and one is A, is the compartment inside. So this part are characterized as a living room and have the condition of interior place. And B is open, have the external conditions to evaluate the propagation of fire. Data of the evolution of temperatures are recorded to thermocouples located at high parapet of first floor and second floor, this part, in order to observe the distribution of temperatures in certain areas of the scenario. Chromatic planes of 2 dimensions are used, like this. More detail, the fire starts in a couch of the scenario in the first floor. Once the fire reaches the stage of flashover, the spirit side to the windows, and the windows are disabled. It's an element, and it are disabled when heat detector reaches 300 degrees Celsius inside near the place of the element of window. So these are the details of the scenario in the part of face front, the facade. The 3 shapes of windows we analyze: square, rectangular, and narrow. And 3 sizes of window: square 150 by 150, large like this 280 by 280 by 180, and the biggest window like this is the horizontal window, which is commonly used in curtain walls. This is very used kind of windows. You can see in this city many buildings with this kind of facade, with this dimension of windows. And regarding outgoing elements, 3 different positions related to the window's openness was considered. One is in the seal element, in the middle of the spandrel, the element of protection, and in the header of the window is this position regarding to the windows. And regarding to the whole facade, we have the 3 different positions, and if 2 elements, projecting elements, vertical projecting, and combined elements with 2 kinds of elements, horizontal and vertical. And 3, regarding the brise soleil, one brise soleil opens 75% and the other one 92%. So the results we have, according to these results, both size and shape of windows are very important factors to consider in controlling fire spreading through the facades. In all 6 cases, shown the influence of the opening factor regarding to the size, length, and shape of the flames. The temperature distribution graph shows a clear difference in the heat flow on the wall for the three window shapes. In rectangular window, for example, in the situation in vertical position, the heat flow tends to take an elongated shape. In narrow windows, for example, this is shorter, the shape of the flames, and takes a curvilinear shape, and this shape then remains very close to the facade. The evolution graphic of heat release rate show a large difference in the evolution of the fire in the compartment due to the size of the windows openings. Is very intense in the case of the largest windows. In this case, in the biggest windows, the heat flux is especially intense even in the second floor of the scenario. In relation to the outgoing elements, the least effective design corresponds to the case where the horizontal projection at the windows is at the sill of the windows. That means in this case, the first one. The heat flow on the facade wall is considerably more intense than the other cases. Is in this part of the facade we have the thermocouple and can show this behavior of the fire. The optimum configuration corresponds to the case where the horizontal projection is located in the header of the window. So is this that case? The projection of the facade avoid the flux on the surface of the facade in the second floor. In relation to the outgoing elements relative to the windows, the results show a very different behavior in every case. We can see clearly that the vertical elements in this case, as we can see in this graphic, the elements act as a channel of the heat flux on the facade and the flames. The eave has the ability to deflect the heat flux and reduce the incidence of the facade and the flux in the facade. In this case, is the better, the eave, but the worst is the elements in vertical position. That's as a channel of the flames. The results regarding brise soleil scenarios show that the presence of a brise soleil, even is an element open, can greatly impact the behavior of the fire propagation. Fire tends to spread only between the interface of the two elements, the brise soleil and the facade. Is because the chimney effect. In the first case, the 75% is more intense than the second scenario. In general, in the scenario, the temperature peaks are about 100 degrees Celsius, being about 19 degrees Celsius in the scenarios without this element of brise soleil. So, as a conclusion of this research, this conclusion is very important from the architectural point of view, from the design of this facade. The building facade geometry can greatly impact the behavior of fire and its propagation on facade. Fire is a sensitive phenomenon to several factors. One is the geometry that is very relative to the design. Therefore, the decisions taken during the design phase can be very important from the fire safety point of view. The window shapes and size are important issues in the fire spread control through the facade. Small windows reduce the risk, the spread because the emitted heat flux is lower in comparison to large windows. An spandrel of 1 meter, as CTE says may be insufficient in some cases, especially when there are large windows. It could be necessary to provide eaves or balconies of 80 centimeters or more to control this kind of propagation. There is a large difference in ability between horizontal and projection elements. As we can saw before, the standard the regulations say that could have the same role, a vertical and going element, but we can see that have a role very different in the behavior of the facade. In this line, I think that the Spanish building code is not adequate. The cavity between layers in facade with brise-soleil system is a potential pathway for fire spreading in situation of fire. Therefore, it's very important to consider the use of barriers to prevent the spread of fire through this kind of cavities and prevent the chimney effect. So that's all from my part. Thank you very much for your attention.